Hello, Keith Rucker here at VintageMachinery.org. Guys, today we're out in the shop and I'm over here at my horizontal milling machine, my K&T Model 2H. I've got my dividing head on here, and what I'm doing is I'm getting ready for a job that I know that's coming up soon, and I need to make an accessory or an adapter, I guess you could say, to be able to use this dividing head for a specific job. So let me kind of zoom in here, show you what's going on, show you what the problem is, and then show you what we're going to do. So first off, this is our dividing head, and what this instrument is used for is for making precision divisions of a circle. And I've been using it, it's set up right now. Last time I used it was for making a bevel gear, and I was cutting 18 teeth, and I need to be able to turn that part 18 different times to get an exact position for each one of those teeth. That is exactly the kind of work a dividing head is set up to do. And you can make pretty much any kind of divisions you need based on the number of teeth or number of splines or whatever it is that you're using the dividing head for. And the way you do that is you have to use a different series of holes on these plates. And there's some charts you can get. You can mathematically solve for pretty much any number of teeth that you have, up to a certain number. I'd have to go look at my thing. I think you can do, with this dividing head, easily 0 to 100 teeth, and then up to several hundred teeth, although there are a couple of combinations in there where there may not be a practical solution. But for all intent and purposes, you can divide out most any kind of pattern that you need. Now, my dividing head is a 40-to-1 ratio, so you have to turn this handle on the front 40 times to make this chuck go around one time. And again, using different hole patterns, you can come up, it might be like 2 turns and so many holes on a certain pattern to get whatever spacing that you're needing. Challenge I've got, and let me just say this too, there's different plates that you can get that have different hole patterns in them. This dividing head, it came with 3 standard plates that really covered most holes, but you also had the option to purchase these high number plates, and these have a lot more increments on them, and they're for doing some of the oddball size spacings. This particular one here, this circle has 57 holes, 67, 77, 87, and 97 holes around there. The job I've got coming up is actually going to require us using this 57 hole pattern. We're actually needing to make a gear with 57 teeth, which is kind of an unusual pattern. And basically, to cut 57 teeth, you turn 40 holes at a time. And because it's a 40-to-1 ratio, you're going to end up using each hole one time, and that will give you 57 teeth. So here's the challenge. I want you to notice between these 2 plates. The standard plate has a larger hole than the high number plates, and that's just because the spacing gets so close with some of these higher values that they had to go to a smaller hole size. And to use those high number plates, you've got to have a different plunger in your dividing head to fit that smaller hole. And that's what we're going to be doing today, guys. I don't have that plunger. When I got my plates, it didn't come with the high number plunger, so we're going to make one. So let's take this over to the bench and see what we got to do to make a proper pin to use those high number plates. So let's start out, just out of curiosity, I want to see what size pin this plate here is and takes. So I've just got my micrometer here, and I'm going to check this pin, and looks like it's measuring maybe just a shade over 140 thou. And to verify that, I got some gauge pins over here, so I'm going to grab a 140 thou gauge pin, verify that on there, and it fits very snugly into that hole. And I'm going to get a 141. This is 141 thou. And it won't go. So it looks like 140 thou, or just under that, is what fits this particular plate. And that's pretty much what we got up here. So this is my high number plate. I want to see what gauge or what size hole that is. Instead of, I don't really have a micrometer or anything to measure down this small, so I'm just going to grab a gauge pin. This is an 80 thou. That's too small. Tell you what, let's go to a 90 thou pin. Okay, that fits, so it's a little loose. Let's go to 100 thou. 100 thou won't quite fit. I'm going to go to 95. 95 doesn't quite fit. So 90 fit, 95 does. I'm going to do a 93. That's roughly almost halfway in between. 93 thou fits. Let's see if a 94 fits in there. 94. It starts, but I could probably force it in there. So I'm going to say that that's what it is 93 thou, or to be more exact, 3/32, which is just a little over 93 thous. So that's about what we need to make our pin size, is 93. To work in this particular hole pattern. So this is spring loaded in here. So it looks like, I imagine what you're going to have is just it's turned down to whatever size that is. And there's a spring, there's a ledge in there, and there's a spring in here that's just captured, and it pushes down on it. So let's pull our cap off the end. This is probably what's holding it all in there. I'm just going to take that set screw completely out. And I'm going to have to probably take a punch and knock that out. It doesn't want to come. So just got to stare at bench block here. That just kind of gives me something to support that. And we'll take a hammer. There we go. All right, that's been polished back there on that Sprite wheel, and it comes right out now. And there's a spring captured up inside of there. See it there? I'm just going to leave it up in there. But that is what we got to make. All right, I think I got a game plan here. A little quick drawing there, just a little sketch of what I need. I went over and I tested the hardness on this end. I just made a little dimple on the very tip of that probe there. And it came out about Rockwell C50, which is fairly hard. Interestingly, I did the top, and it's much softer. So it looks like what they did was they did a heat treat on this, probably just treated that end down there, didn't bother about everything else. And a little bit of research to get to Rockwell C50. I believe I can make this part out of some 4140. And what I'll need to do is I'll need to just heat that end up red hot. I can probably just use a torch. It won't take much to just get that tip hot, quench it in water, and then anneal it in my heat treat oven at about 500 degrees for 2 hours. And that should, according to the book, get me somewhere close to that Rockwell C50. And I say it's about C50. My hardness tester really only measures in about increments of about 5, and it's somewhere close, and it was hard for me to get a real good measurement on it because it was just such a small area up there. But that should be pretty close, and that will make that tip a little bit more wear resistant. It'll make it a little bit harder than the plates, so it won't wear down as easily over time. So I got me a piece of stock hen. This is a 7/16 inch diameter, which is basically the same diameter as this area right here. And this is some 4140 steel. Should be able to get that hardened on that tip like we need to. I'm over on the Revette lathe, a little smaller lathe. This is ideal for this machine, so we're going to use it. I don't get to use it as often. Like this little Revette lathe, little tool room lathe does a really good job. Typically use it on smaller parts like this. come in here with a center drill and just put a little small center in that end. The original had a center in it. That gives us a little bit extra support while we're turning that smaller diameter. And now we're going to put a center in the end there just to give us some support. A little mark there on how deep I want to turn it. Just changing out tools here. That last one I had in there won't let me get in up by that live center. I'm going to touch off there and just turn down there. Going to 5/16 on this, which is point 0.3125, and we're about 0.41, so we got 100 thou to take off of it. It's taking about 7 thou here. Should get us real close to the final measurement. I think I need about 1 more thou. Gonna fuzz a little bit off here. We'll get down to the bottom there and we'll face that back side as well. Now I want to come in here and put a little chamfer on the end. If you look, this one's kind of rounded over and it's roughly that same angle as this cutter. So I'm just going to come in here and start with a chamfer. About like that. Then we'll just kind of take a file and blend that top over to kind of round it out like the original. That looks pretty good. Pretty similar there. All right, I think we got the stem done. We'll turn it around and turn the tip. So I want to go ahead and cut this off. I'm just kind of, again, holding my original in there to get a rough length on it. And I've got a parting tool in here. There we go. So if you look at the original, it has a radius back here in this back where that little pin comes in. So I have found a piece of high-speed steel that was ground to a radius over in my bin, and that's what I'm going to just kind of use to go up and try to form that radius in there. Just give me a mark to work off of. And that has got to be turned down. Well, it will go down to 0.93. I'm probably just going to shoot for something a little over 100 thou. I want to turn it a little bit oversized, and then I'm going to grind it to the final size after we do our heat treat. So just going to come in here, and I'm going to see how this cutter's going to cut. Because it is a form cutter, it's going to be taking a pretty big bite down there in that radius. I'm going to just kind of sneak up on this thing. Not try to take too much of a bite at one time, too much of a cut at one time. Should be the last pass here. And I'm just going to kind of carefully form in. All right, so we're just a tad over 100 thou. That'll give me a little bit to grind off. And going to hit this with a little bit of emery. Break those corners. Kind of polish it up. You can see this is the original, this is the new one. And like I said, I've still got about roughly 10 thou that I'll grind off of that after we do our heat treat. But before I do the heat treat, I do want to go ahead and mill this little slot up here in the top. My plan is I'm only going to harden the bottom, but just in case it gets a little bit harder up here at the top, I want to go ahead and put that in there before we heat treat. And that way we don't run the risk of messing the cutter up trying to put that in there. Let me go over to the milling machine. I'll get that set up and we'll get that put in. So here's the challenge. How do you hold this pin here that has this shoulder back here in your vise so it's nice and tight? You know, you put it in here, it's going to be flopping up and down this way, and you're only really going to be able to grip it on the widest part. So, simple solution. What I've got is a couple of V blocks, and I'm going to take one put in here. We'll put that in the back. I'll take its matching pair, put in the other side. See here, we'll just do it this way. Now I can slide that piece in there, and I'm gripping it on the shank where I want to hold it at. It's going to keep it nice and square in all directions, and my work holding's done. I've got a couple of marks on there on the top. That's just roughly the position, the location of my slot that I want to cut in there, a little flat. Got a 3/16 inch wide end mill in there, which is the size of the slot. I'm just going to come down, touch off on this. It's touched off there, and we'll just raise it up a little bit. Cut across. Doesn't need much. Kind of looked at the original. That's pretty similar. So I think we're fine right there. To harden this, I'm just going to use a torch, and we're going to heat the very tip up until it's a cherry red color. It won't take very much heat at all to do that, as small as that is. And then we'll just quench it in a bucket of water. What that will do is that will harden the steel. And the reason I'm doing it this way rather than using my heat treat oven is, in this case, I really don't want to harden the whole pin. I just want to harden the tip down here, and that's it. So I'm only going to heat the tip up, and we will harden it. Once it's hardened, it's going to be too hard, and we need to back it off a little bit. We'll temper it using the heat treat oven, and I'll go over that in a minute, but that will get it down where it will hopefully be hard and tough, but not really hard and brittle, which is what we want to avoid. So let me get my torch fired up, and we'll get this thing heated up and hardened. All right, we got a nice blue flame there, and again, I'm not trying to heat the whole part up, just that tip. And I'm trying to do this a little bit on the slow side. I don't want to do it too fast. Because of that thicker piece beneath it, it's kind of like a heat sink. So I'm really kind of heating that up and letting the heat draw out into the pin. And it's starting to turn a light red. And that's fine, we'll quench it. You can kind of see here a gradient in the color of this metal. It was semi-polished, so this is an indication of hardness. And this is actually after you temper it, but because it didn't get up to full temperature down on this end, that straw and blue colors kind of give you an idea of how hard it is. Really doesn't mean anything right now, but that is an old blacksmith's way of looking at hardness rather than actually testing it with a hardness tester. You could just look at the colors in there and you can see it pretty evident there. I wanted to show you that. Again, the tip is too hard right now. According to the book, it should be at about Rockwell 60. I want to get this down to about Rockwell 50, maybe even a little bit lower than 50, probably 47 to 50, somewhere in that ballpark. And according to the book, after doing what I just did, if I heat this up to, I need to double check, it's either 500 or 600 degrees, hold it there for 2 hours and let it cool down. It will draw that temper out, or draw that hardness out, and make it a little bit softer. Still hard, but not as hard as it is right now. Right now, this tip is super, super hard. If you were to drop this pin, this is almost like a piece of glass. It could fracture. We want it to be hard, but we also want it to have some toughness to it so that it won't break. And by drawing that temper back, that's what we'll do. Got my Hotshot 360 heat treat oven going here, and I just got it in manual mode. We're gonna go to 500 degrees. We're gonna hold it there for 2 hours. So I'm just gonna go ahead, let me turn my coils off. I'm just gonna set this in here, turn my coils back on, and we'll just let it go for about 2 hours. I'm gonna just watch the clock, and then we'll just turn the power off to it, or not turn the power off, but turn the heat off to it and just let it cool down nice and slow. And when we get through, according to the book again, that should get my hardness around Rockwell, what was it, 47 to 50, somewhere in that ballpark. Well, I finished the heat treat on this, and I didn't really show it. All I did was pull it out of the oven after it had cooled down, but we got our part here. It has been completely heat treated. It's been hardened and tempered. Again, this bottom end down here, the pin should be around 48 Rockwell, somewhere in that ballpark. The rest of it is still fairly soft. And I turned this purposely about 100 or about 10 thousandths, excuse me, oversized, and I needed to get it down to the final size. And to do that, we're gonna do that over here on the grinder. And I'm gonna do it on my surface grinder. And what I've got here is just a spin fixture. This has just got a 5C collet in it, and we got the collet in there for that size shaft. And what this allows me to do is just spin this by hand. And that's all I'm going to be doing. Instead of trying to do angles or something with it, I'm just using this to create a rotary motion. Ideally, I'd have a motorized spinner here, but I'm just going to do it by hand. And I am on the surface grinder, so what we'll do is I'm going to dress this wheel, and we will come in here, it will touch off on this, and we're going to grind off that roughly 10 thousandths of an inch to get it down to a precision measurement. Now, my measurement needs to be about 93 thousandths. And I've got a gauge pin here and a micrometer that we'll check it with. My gauge pin, I know this gauge pin will fit, so I just checked my micrometer with the gauge pin, and it is reading 93 thou. Actually, this is a minus gauge pin, so it's about a 10 thousandth under 93. And that's what we're going to shoot for, somewhere really close to 93 or just a few 10 thousandths under that. And we'll do this on the surface grinder. I'll come in here, we're just going to move our fixture over here to roughly the center of the wheel, and it's actually, the height is about right there. Need to come up just a little bit, and we'll start grinding that. So guys, I did dress my wheel off camera, and what I'm going to do now is just bring this pin in. I'm going to start spinning it, and I'm going to slowly start moving my head down here until I get a touch off. I'm just barely seeing some sparks there. I'm gonna look and see where I'm at. I know I've got about 10 thou to go, but guys, remember, because we're spinning this, it's like a lathe. We're basically cutting material on both sides, so I only need to go down about 5 thou. And I'm on about 23 9/10 right now. So I'm just gonna real carefully start feeding down. I'll come down about 1 thou. About 2 thou. About 3 thou. About 4 thou right there. That's about 4.5 thou. And I think what I'm gonna do is pull out, and I'm gonna get in there with my micrometer and see where I'm at and how much farther I need to go. And guys, I'm gonna do this with the wheel running, being really, really careful here. All right, so we are right at 101 thou, so I still got a little ways to go. So I should have about another 8 thou now that I've got a real measurement here. So that's going to be about 4 thou total down feed. There's 1 thou, 2, 3, 3.5. Do that till it sparks out. And again, let me get another measurement. I'm 1 thou over, which is right where I thought I'd be. So I'm gonna go down about 1/2 thou. I think I'm gonna do 6/10, which is right there. All right, I'm just a tad under. That looks like about 92 7/10. That should be just right. All right, I think we got our grinding done. So guys, I've got this on my dividing head now. I put the small pin in. I've got in this high number plate, and we can go anywhere along that circle and index it on one of those pins. So I think we are ready to go, and I've got a buddy of mine who needs a 57 tooth gear made, which is why we needed to go to this high number plate. The only plate that you can get a 57 tooth gear made out of on a 40-to-1 dividing head is on a 57 hole, and you go 40 pins per turn, and you'll use all 57 of those holes to make your final gear. So we'll get this set up, and I don't know, he's coming up, he's going to do that job himself. He's just going to borrow my machine and my dividing head, but maybe we'll get a little video of him doing that job for you guys to see. But the project is a success. We have a nice pin to use the high number plates with my K&T Model H dividing head. Well, there we go, guys. That is going to be a wrap on yet another project, something we needed to make to be able to use our tools properly here in the machine shop. And I've said it many times before, one of the great things about having a machine shop is that when you need something like this, you don't have to go buy it or try to find it. In this case, this part, you can't go buy it anymore. At least I don't know where you would get it. K&T is no longer in business, and I don't know of anybody that's selling parts for these things. So no problem. We'll just make our own. And that's exactly what we did here. As always, guys, thanks for watching the video. Please subscribe to the channel if you haven't already, and those comments and thumbs up are appreciated. Catch you on the next video. Thanks for watching.